This video is on homework 2 for the IST852 Knowledge Management class. The purpose of this homework is to develop a simple knowledge-based system to calculate bonuses and surcharges for an example insurance company. The bonuses and surcharges are determined by applying a set of rules based on the customer's age, home address, sex, type of car, etc. To create the system, we'll need to download and install some software and configure our environment. The first piece of software we'll install is the SQLite Manager plugin for Firefox. To install this, we'll open Firefox, go to Tools, Add-ons, select Extensions, and then search all add-ons. We'll type SQLite Manager. And then click the Install button for SQLite Manager. Once this is installed, we'll restart Firefox. Good. And to make it easier to access, we'll create a desktop shortcut which will open SQLite Manager directly. So we'll do this new shortcut. In the location, we'll type program files, x86, Firefox. Good, and then click Next, and we'll name it SQLite Manager. So this shortcut should open SQLite Manager for us. Great, next we'll download and install the Clips software. Clips is the expert system tool which we'll use to apply our insurance bonus and surcharge rules. And Clips can be found at, Clips can be found at http Clips rules. Oh, not typing up there. Clips rules sourceforge.net. Right, and then just click on Download Clips. And then pick the one for your executable or for your system. So you can see the executable for Mac or for Windows or for Windows 64, whichever one fits the system you're using. I've already downloaded this, so I'm going to skip this step, but I've downloaded the Windows 64-bit executable. And then to install it, we'll just find the download and double-click the executable. And we'll just accept the defaults. And it just takes a minute to install. And then once that's installed, we'll go and create a desktop shortcut for that as well. Good. And the last piece of software we'll need is Anaconda Python version 3.6. This version also includes the Jupyter Notebook, which we will discuss later. Python is a powerful programming language, and in this case, we'll use it to extract data from the database and complete some calculations. So Anaconda Python can be found at https://www.anaconda.com/download. And again, pick the version that's appropriate for your system. I've already downloaded the version for Windows. To install, just double-click the download. And accept the defaults. When that finishes, we'll click Next, and we'll uncheck these two things, and then click Finish. Now that that's done, let's go ahead and create a desktop shortcut for the Jupyter Notebook as well. Okay, great. Now that our software is installed, we can get started. First step is to create a working directory for our project. We'll create this directory under our Documents folder, and then we'll copy in text files containing the commands we'll use for steps 2, 3, and 4. These commands can be cut and paste into the appropriate applications, so you don't need to watch me type them. So we'll call our folder Homework 2. And then we'll go to our Downloads folder and get the text files for steps 2 through 4. During step 2, we will create the SQLite database to store our data. The database structure will implement this entity relationship diagram. From this diagram, we can see that there are 3 entities. The contracts entity contains information about the customer and their insurance contract. There is a relationship between the contracts entity and the cities entity describing where the customer lives. Many customers can live in a city, but a customer can only live in one city. The cities entity keeps track of the population in each city. We will need this information later. There is also a similar relationship between contracts and cars. The cars entity contains information specific to a car. To create the database, we will use the SQLite Manager by selecting the shortcut we created on our desktop. But first we need to open the text file containing the SQL commands we will run. We'll then create a new database, and we'll call it insurance.SQLite. And we'll save that in our project directory. Now that this is complete, we can copy and paste our SQL statements to create the tables, one for each entity. Okay, we can see our 3 tables have been created. Now we'll also create a view which joins the 3 tables together, but also adds a new column called Insurance Class. And this new column will contain data from the contract class, but it limits the maximum value of this new column to 15. And we can see that our new view is now created. So now that the tables in view has been created, we will populate the database by pasting in these insert statements. Good, so we can double check these. We'll look at the cars and we can select browse and we can see that there's data in cars, there is data in cities, and there is data in contracts. And if we look at the views, we can see the view is populated. Good. At this point, we're done with SQLite Manager, so we can close the program in the text file. Next, we'll copy the test file for step 4 to the constructs.clp file. This file contains the CLIPS templates and rules necessary to determine the final price a customer will pay for insurance. Conditions for these rules are: for bonuses, customers from smaller cities will save 35% off the base price, but no other discount can be combined with this one. Customers aged 27 and older save 10%. Female customers with small cars save 5%. And new customers with contracts started in the last 30 days receive a $50 bonus. As for surcharges, if you own a luxury car, you'll pay 10% more, and a sports car will cost you $100 more. By looking at the text file, we can see how these rules are implemented. First, we create a template in CLIPS. Templates are used to describe an object. In this case, the object is a contract. Next, we'll create the rules necessary to calculate the final price. The very first rule we want to check is the city population rule. Since we don't want customers getting any additional discounts if they get this one, by setting the highest salience to this rule, we can force CLIPS to execute it first. There's the salience. This rule will fire if the contract's no more bonus is set to false, the driver's city population is less than 100,000, and a base price exists. If these conditions are met, the rule will set the final price to 65% of the base price and flag the contract so that no more bonuses will be applied. The next rule will set the final price equal to the base price when no more bonus is false, a base price exists, and the final price is currently 0. This rule will fire second based on its salience of 15. The next 3 bonus rules adjust the final price if the conditions are met. They have a lower salience, so they will fire only after the first two have completed. Each will change the primary fact causing the rule to fire, age, car displacement, or new customer, so that the rule will not fire more than once. Since we want surcharges to apply after the bonuses, the rules for these have the lowest salience. Each will modify the final price if the conditions are met and change the primary fact so the rules will only fire once. The inference engine in CLIPS will use these rules and facts to come up with a final price based on whether or not the conditions have been met. Now that we're done with step 4, we'll move on to step 5 and download the Python program and save that to our working directory. And we'll open this program with the Jupyter Notebook. Okay, we can find this in our, go to our working directory now within Jupyter Notebook, and we'll open up the Python program. The purpose of this program is to read the data from the database, do some calculations to it, and format it as facts, which will then get imported into CLIPS. If we look down at some of the commands that are run here, we can see that we're calculating the base price. We're going to calculate or set a flag for new customers based on 30 days. We'll also calculate the driver's age based on their birth date and make some other settings. So one thing we have to do is modify this to work in our environment. So we'll see here the location of the database will have to be set. So our database is at C users, owner, documents, homework 2, insurance.SQLite. And then if we look down below a little bit further, we'll see where we're going to create the facts.txt file, which will get imported into CLIPS. So we want to change the working directory for that to be our working directory. Great. So these other commands down below here, below at facts.txt, we're going to execute after we run facts.txt into CLIPS. So we'll come back to these, but we can change this portion here. We'll change this to be our working directory also at this point. So these steps down below will be executed at step 7, I believe. So what we'll do now is we'll just highlight what we want to execute from this portion all the way up to the top. That's going to be the last one, and this up to the top here. And then we'll go to cell and then run cells. So if everything worked correctly, which it looks like it did, we should be able to look in our homework 2 directory, and we'll refresh. And we should see the facts.txt file, which was created with our 4 facts in it. Now that we've confirmed our facts.txt, we will open this up in Clips. And we're going to, first we're going to load our template and roles. These were saved in this constructs.clp file earlier. Okay, good. And then we'll load our facts from facts.txt. Great, and now we'll execute the rules by using the run command. And then we'll save the resulting facts to a facts underscore edited text file. And this file will then get brought back into Python to do some final formatting. Okay, great, that's done. I think if we look here now, we should see facts edited. Perfect. And it contains some information. Excellent. So now we'll open our Jupyter Notebook again and scroll down to the bottom. Right, and now we want to execute these last few commands. So we'll do that. We'll highlight them and select cell and then run cells. And when we scroll to the bottom, we can see our very nicely formatted result. So this concludes my demonstration of Homework 2. Thanks for watching.